So I'm here to finish you off with some very low-level stuff. It's a talk I did like 5 or 6 years ago at this very conference. It has sparkled some reaction. I hope it will today too. Before that, I would like to thanks Alexei for your presentation. I love core data and what you did is awesome. I actually found your repository before, I don't know how, and I was following it and I was saying, oh, 1.0 reached today. That's amazing. Anyway, so Swizzling and extenders. So Swizzling, you've probably heard about. Extenders, maybe if you have followed the talk I did last time. Let's start with the demo. As you might guess, the demo will be not very impressive. How do I exit this? I don't know. I cannot exit. Yeah, I tried. I told you.
Ah, super.
Hmm, incredible. Yes. All right. Let's see. Does it work? So we start with method swizzling.
Non, pour le micro.
Ça va.
Non, non, c'est bon.
All right. Beautiful simulator. App is installing. Okay. Launching. Runtime fun because it's what we're doing. All right, let's see the logs. Yes, we can see. And now I'm clicking on view and we can see all of these logs. So I'm called inside the my touches began with event. And the interesting part is this is an actual view without subclassing. And if I click on this one, we can see a lot more stuff, which starts here. And we can see that we're in my touches began with event in a container view, and then we can see we go up the hierarchy, map view container, map view, UI view, method swizzling, etc., etc. We go all up the responder chain. Yeah, I can see some faces which look a bit startled, but that's what's actually happening behind the scene when you click on a view. If the view doesn't do anything, it goes up and up and up and up in the hierarchy until the root is reached. And I did this talk like 5 years ago, and when I did that, there are three ways. We'll see that later, but there are three ways to do swizzling, and I implemented this swizzling in three different ways. And the one I'm here to talk about is the one I implemented. Is the only one that still works 5 years later. So I was happy. Anyways, let's go back. So yeah, that was the whole point of the demo, to see that you can actually do things without subclassing. It's not very impressive, I told you. Anyways, so why would you want to do that? First off, you can debug some framework you don't have control over. Like for instance, let's say you have a framework. Let's say you launch your app. You have integrated one framework or updated a framework or whatever, and so suddenly you just launched the app and you have the pop-up requesting permission for notifications. That's very annoying because you have carefully planned for the pop-up to appear at this exact time so that you can actually have the user clicking, okay, I want to have notifications. Yes, please spam me. And no, so you don't know what frameworks does that and why and stuff like that. So what you do, you just swizzle the function that actually triggers this, and you put a breakpoint in your code, and you have the stack trace, and then you can say, oh, this is this one. Next, you can also enhance some built-in methods. Like say, for instance, you want to send an analytics event every time a view appear, just whistle view it here, and you send your analytic method. You can retrieve the name of the class with some other runtime stuff. And finally, you can work around some framework limitations. Let's say, for instance, you have found your framework that you want to kill in Fire, and you just swizzle the method inside the framework that does the triggering to say do nothing instead, and you have successfully pruned the framework. I have another example that I did recently. I didn't do that like 5 years ago. It's very recent. At Mojo, I work at Mojo now. We have done. I'm working on the engine. So basically, we have a JSON that represents an animation, and that's what is displayed on the screen when you edit a project. It's just a JSON that you edit. And for tests, we wanted to take a JSON, output a video. And to do that, I actually did a CLI tool, so command line tool, that had the entire engine in a Catalyst app, so a Catalyst command line tool. And we had some problems with resources because we were using bundle.main, which doesn't exist in a command line tool or does not exist at the correct location we wanted. So I swizzled the main method of main to return the bundle I wanted. And so that's another example of using Swizzling. So even though the talk is old, even though we are now switching to Swift and there is not much dynamicism as much as before, it's still useful sometimes. Anyways, how does it work? Traditional method dispatch, usually in a normal language, when you call a function, the method is either called directly because there is no subclassing and you can just say, oh, it's an object, and you have exactly the address of the function and you can call it directly, or using a virtual table, which will allow resolving the subclassing. So let's say, for instance, I have a vehicle class and you have a car a subclass and a bike subclass. And when I say move, which method should I call? Whether is it the method of the car or the method of the bike? So this is resolved at runtime using a vtable. So that's in a normal language. Objective C did something a little bit different. You have your object, you call a function, the actual line is transformed by the compiler into a function call. The function is Objective-C message send, which is probably one of the most optimized function in the world. I think, if I remember correctly, there are some actual processor instruction just to have this method go faster. So yeah, it's very, very, very heavily optimized. And what does this do? It will basically search in a list of symbols, find the address of the function to call. And the interesting thing with this function is that if the method does not exist, there are ways to recover and call another function instead. Why not? It's the dynamicism of the Objective-C runtime. And you can also say this object now has a different implementation for this symbol, etc., etc. And so that's what we do when we swizzle. That's actually what's done. We do change the function implementation for a symbol. So yeah, exactly. Thank you for whoever wrote this slide. It's amazing. Okay, so that's how you usually not really anymore. 5 years ago, that's how you usually swizzle a function. So it's a bit complex. We'll break it down. Yes, amazing. I mean, oh, every time. Okay, what does it do? Basically, you have your infamous table with a class name and the method name and an address for this for to call for this selector. So in our case, we have print hello function in the hello class, and we want to swizzle it with swz for swizzle. I will say swizzle from now on. Swizzle print hello. So what we do is we just invert the implementation of the two, and we have an infinite loop in the implementation of swizzle print hello. As you can see, first we do a log to say, hey, I have successfully swizzled, and then I call myself. I call swizzle print hello. So why? Because we have inverted the implementation. So now when I call swizzle print hello, I will actually call the original print hello function. Okay, so this is the implementation. If there were no subclassing possible, it would be as simple as that. Basically, you take your original method implementation. So the method object is a method is a type from Objective C, which represents the implementation of the method. So you get first your original method for the original selector, the swizzle method for the swizzle selector, and then you just call method exchange implementations, which does exactly what's written. And then what does happen when you have a child? A lot does, but you cannot just invert the implementation of the methods, because if you do, you will call print hello on your parent instead of the child. So you have to insert first the method print hello inside the child, and then you can exchange the implementation with the child. So now the child's swizzle print hello will call the original print hello, and it works. It's a bit complex. Even I have trouble following. Anyway, so that's the end of the method. First, you try and add your swizzled method inside your class, and if the class is added, you replace the method of the child. Otherwise, you exchange the implementation. So that's the common implementation you can find on NS Hipster. There is, oh yeah, on the final lines is just to do it once. You dispatch once. Otherwise, if you do that multiple times, no one knows what will happen. And there is also an implementation to do that more or less automatically. And also it fixes a few issues, but not all of them. We'll see one more issue. Let's get ready for something even mind-blowing. Even I have trouble following. What happens if you have two children, sorry? We have a hierarchy, so the root, and then the root has a child, and then the child has another child. Then the root has a method called hello, and then you swivel hello in the second child, so at the bottom of the hierarchy. So you have, and then you swivel again hello in the first child. So what happens is this: you have the class child who two, which has the method hello, which will go to address number 3, child 1, which has hello, which will go to address number 2. But what you realize, you can do the math at home. I mean, I understand if you're lost, but trust me when I say this: if you called hello on child 2, the method for hello on child 1 will never been called. So how to fix this? You do the swizzling in the proper order. First, do swizzling in child 1 and then in child 2. So that when you do the swizzling in child 2, you are aware that there is a function inside child 1, and you call this method instead. There is another solution, use FRZ Swizzling, which is the Swizzling implementation I have done, which fixes this issue and fixes also other subtle Swizzling bugs, and also other non-subtle Swizzling bugs. Let's say, for instance, that you okay, how okay, this is a common problem with Swizzling. Whenever you call a Swizzling, have you seen in let's come back because it will be easier with an example. There is, anyway, sorry about that. I have to find the method. Yes, here you can see that in your Swizzling implementation, you call yourself, so you call swz print hello. The problem with that is the selector name with which you call yourself will have changed. And that's actually an issue sometimes. For instance, in the example I showed earlier, in the demo I showed, when we do the swizzling using this method, this common implementation, we're called only once. And when I showed the demo, we're called in the whole hierarchy. That's because for some reason, which I do not know, uh, foundation will call the parent responder using some obscure forwarding methods, which will which will not use the original selector name, but which will use the selector name in with which it is called. And so you're only called in your Swizzling once. So this is also fixed with my Swizzling implementation. I'm not aware of many implementation of the Swizzling that does that, but I know there is a post which is now archived on a New Relic, which actually presented the solution I did for the Swizzling. So to swizzle with FRZ Swizzling, you do things a bit differently. Like I told you before, when you dispatch, when you call a method in Objective C, you are just calling a function. Actually, you all know that when you're in a method, the self and underscore CMD uh, arguments are there because you're actually coding a function. The compiler changes the thing. So to do the swizzling, you do this like so. Let's review. The first line will be a pointer to the original implementation of the function. Then you have your own function in which you can do whatever you want, but you usually also have to call the original function. And then you do the swizzle using you calling FSZ check swizzle. You pass in the class name, then the selector name, then your implementation, then the original implementation, and that's it. You can do that in a load method, for instance. That's pretty much it. And this fixes all of the issues. And it also fixes the double inverted swizzling. I think I am the only implementation doing this, and the reason for that is because there is a state that you have to keep in order to be able to do that, and that requires cooperation with other swizzling methods. So if you use only my framework to do the swizzling, the double inverted swizzling will be correct, but if you use other methods, it won't because it's just not possible. Okay, so this is open source. You can find it on my GitHub. It's actually coming from Happen, but I forked it because I'm not working at Happen anymore. I have no shame. Anyway, now let's talk about ISA Swizzling. Like, so what is ISA Swizzling? It's basically I think it's more or less simpler that method swizzling. Basically, you just change the type of an object at runtime. So let's take the example of the bike and the vehicle, bike and car from earlier. I have my vehicle, which is a car, and I just say, now you're a bike, and at the end of it. So of course, in order for that to work, there are some limitations, like for instance, the memory layout must be the same. There must not be more variables, etc., etc. But basically, it's very simple. You just call object sec class, and you're done with it. And this is actually how KVO works. So when I say I want to observe a property, KVO will create at runtime a subclass of your class in which the accessor of and setter, of course, of your property will be overridden, and the proper handler method for KVO will be called, and your registered observer will be called. So that's how it works. That's fucked up. Anyway, I have a slight poll. So bear in mind that was 5 or 6 years ago. Who wrote a subclass of UI view controller that says my company view controller, whatever, that does some tweaking on the UI to have some global configuration of the UI? Okay. Now we'll do stuff to Swift. I know it doesn't exist anymore. UIKit is dead. But anyways, there is a solution to avoid that. You just just do an extender. So what happens is you have your init of your view controller, and you can just add an extender on your class, and the whole behavior of the class will be changed. Like you can, for instance, automatically uh, change things in view did appear, but you do that in something else. Why is that useful? Because if you subclass UI view controller, you have to also subclass UI navigation, UI collection view controllers in a way, UI table view controller, etc., etc., etc. With an extender, you can deport the code that does the the tweaking in a separate class, and then you just apply it on your view controllers. I have done that in production. It works, and it has worked for years. It does not work anymore on UI view controllers on Vision OS, but it still works on iOS, and I expect it to work like pretty much forever until there is a huge drop of UIKit. So basically, an extender is subclassing with subclassing. So just like KVO, when you add an extender to a class, a subclass is created for you, and then your object is changed class. It allows, for instance, taking over delegates. Like if you have a table view and you want to, I don't know, do stuff inside the delegate because you're a bit crazy, it's possible. I don't know. You can actually do an extender of table view and take over set delegate to actually set your own delegate that will forward then to another to the original delegate. That has been done in prod with a bit of trouble, but it eventually was stable. Also, you can transform a single delegate to a multi-delegate. So let's say I want to be notified when something happens, etc., etc. It's cool. It's yeah. You will decide if it was a good idea or not. I have no judgment. I did that, so I have. I loved it. Yeah, I mean, it was fun, but yeah, times have changed. So a simple example. Let's take an example. So we have a table view with a button in it. So if you tap on the button and scroll, the table view will not scroll. I hate this behavior. So I just add an extender on the table view. And now when I scroll the from the button, oh, okay, now see, this is the example where it doesn't work. But basically, when I scroll from the button, it works. So the traditional solution is to subpass UI table view, override touches should conserve in view, and change the type of your view to the custom subclass. And the problem is what happens when you have a UI collection view, but you have to do the same for the collection view. It's very annoying. Using an extender, you configure your extender to say that you want the touches to be okay when it's a button, but not when it's something else. I don't know. Doesn't matter. Then you add the extender to your table view or collection view or any square view, and that's what's the beauty of it. And even if it's not yours, this means you can actually customize framework level stuff because it's just changed at runtime, so the framework will never know. And then you're done. How does it work? So this is a part where even I don't even actually know because I've coded that very, very long time ago. It's very complicated. But basically, the idea is simple. That's good. There are three components. The first component, which is the definition of the extender, is a protocol. So it's what's possible to add to your object. Then there is the help tender, which is the implementation of this protocol. So basically, if you want to add functionality to UI scroll view, like the example we saw, you just create a subclass of UI scroll view, indeed, and you override the method you want and call the extenders from this method. And there is the protocol implementation, which is the actual, which is the code you will create as a client of an help tender. So the protocol and the help tender are linked. and you will see why right now. So to add an extender to an object, you take your extender instance, you see what protocols it conforms to. So the protocols we've seen earlier. We get the linked help tenders. Then we build a subclass, and this is the magic, and this is what was complicated. We build a subclass of the destination object in which all of the methods of the help tenders will be copied. And then you change the class of the destination object. So the one of the bigger difficulty was to actually have a name which is table. So you have to the names have to be unique. So you cannot create twice the same class. And you also might want to know the actual name of the class when you have a crush in that and stuff like that. Also, you shouldn't mix this with KVO because otherwise KVO will not know what's the actual class name, etc., etc. So let's do a quick demo of that. Oh yeah, it worked. Okay, so I have actually two demos. So this is in the simulator. So this is basically what I've just shown earlier. This is the button. I scroll the button. Let's see how it's implemented. Is a Swizzling iOS. So the first part, this is the protocol, the extender protocol, and you are allowed to change the behavior attached should cancel in the content view. And below you have the help tender. And the help tender implementation, just like I said, okay, first it's as you can see, it's a subclass of UI scroll view. And then you can see that touch should cancel in content view is overridden. Then you call super. So the calling super is a bit complicated because you're in a class that is auto-generated at runtime, which means that if you call super, you will call the actual super when the code was compiled, which is UI scroll view. But you are now a collection view or whatever. So there is a helper method, which is actually a DS defined, but it doesn't matter, which will call the actual super of the object now at runtime. So yeah, you just have to know that. And the implementation is very complicated. I don't even remember how it works. And then for all of the extenders that are added on the object, you can verify that it supports the extension, and then you build your modified result, and then you call the result, and that's it. So building the help tender is the complex part. There is a small library of help tender that exists. You can reuse them, and once you have the help tender, it's very easy to use. You just call xtz check stack add extender on the table view with the custom cancelable touch SVE, which is your implementation as a client of the of the extender, in which you can do actually what makes sense for your business logic. Okay. There is another use case which is a bit crazier, so I will just show it on passing, but it's more fun than anything. Okay, so I'm creating an object, which is an NS object that I bitcast into an NS number because I add an object extender on the object. And the object extender is it's linked to an object help tender, which will do some some runtime magic to actually forward unknown selectors. So basically, that means that if you call an NS object, an NS number method on your NS object, the help tender will be called instead, and then it will the help tender will return a value. it actually works, as you can see. Let's run it again because it was still in the log of the other thing. So creating runtime help tender, and then we are here, YOLO one. The value is A1, which is object, an NS object, as we can see here, and we call decimal value on that, and yet we have an answer, and there is no crash. Everything works well. And as we can see on here, YOLO 3, we have added the extender number 2, which has the value 21, so that works. That's good. And if we remove the extender, the last thing, we call decimal value on the same object, still the same object. And this time, we do have an exception and recognize selector sent to instance. So yeah, that's fun. A bit useless, but it's fun. I don't know. I think I actually had a use for that, but I don't remember what it was. Must have been very smart, but I don't know what it was. Anyway, use this example. As I told you at the beginning, my company view controller extender to tweak the design of your app automatically on any your view controller, modifying the behavior of an SDK again. Custom cancelable touches for scroll view, like I told you, anti-scroll extender. So this is not needed anymore, but basically the idea is to have a subview of a scroll view which doesn't move when we scroll, but now we can do that with constraints, so it doesn't matter. Inverted SVE. So this one was very interesting one. Basically, the idea was to have an inverted scroll. So when you have a chat view, usually you have either a table view or a collection view, and you have trouble maintaining the scroll when you get new messages because staying at the bottom or at the proper location is very, very hard. Which, by the way, I recommend ChatKit, which is, I think it's called ChatKit by a Ukrainian developer. I don't remember his name, and it's an amazing piece of technology. The guy actually looked how the collection view layout thingy worked, and it's incredible work. Anyways, you can also do that, do extenders for anything you want. I actually use that in a modern project, to implement the coordinator pattern to be notified when a view controller is dismissed, in order to have the coordinator be able to notify its parents that the view is gone. So it's convenient. Anyways, it's open source. It has example of a help tender if you want to use them, because this is the hard part to code. And that's it for me. Conclusion: the runtime of Objective-C is highly dynamic. No, shit, shut up. Sorry. Swizzling can be very useful for debugging, of course, and it's useful sometimes in production. Do you have any questions? Or did I lose everybody?
Thank you, François. It was really fun to deep dive into back technologies. Do we have some questions? Yes.
Fun talk. Did you play with the Swizzling solution using in Swift, such as at dynamic replacement or things like that?
No.
Okay.
I know it exists, and yeah, it's much safer than using Swizzling this way, of course. And but I haven't used it. I've just seen it in passing.
Another question? Yes.
So two questions. The first one is a troll question: is would you actually use that today?
Yeah.
And the second question is, I understand that the help tender cannot really be implemented in Swift, but like the whole framework, can it be used from Swift, or do you have to write Objective-C?
Okay. So yeah, I am actually using that in prod, yes, currently. But like I told you, it was for automatically detecting when a view controller is dismissed, and yeah, it's very convenient. And also actually move the implementation logic of this detection at the proper location, because UIKit is not good for that. It's just the fact of the matter is it's not good for that. And so basically you have cleaner code in a way. So it's anyway, I won't enter into the details. Yeah, in my opinion, it's actually cleaner. And other than that, yes, help tender have to be written in Objective-C, but that's the only thing. No, there are two things. For ISA Swizzling and extenders, you can use everything, including extender implementation, in Swift. You just have to write the help tender implementation in Objective-C. For method Swizzling, you have to go back to Objective-C or use the new Swift Swizzling.
You mean for your way of doing method Swizzling, right?
The other one too, I think. Yeah, but the other one is a bit. I'm not sure. Honestly, I'm not sure. GR Swizzle is just a method call, so maybe it works. Yeah, I'm not. I don't know.
You have another question.
T'en as eu? Bah, vas-y.
Okay, last question. You mentioned that you're using ISA Swizzling for your approach, and it is not compatible with KVO. So you're basically assuming that UIKit doesn't use KVO with UI table view and UI collection view.
Basically, yes. There are also workarounds to make it work with KVO. I have an unsafe flag you can just enable, and it works with KVO.
Okay.
One last question. I think the pizzas have arrived and people are starting to be hungry. Thank you, François.